Class 9 Science, Chapter 4, Structure of the Atom, and in this video I will explain the answers of exercise questions of NCERT book. Now first question, compare the properties of electrons, protons and neutrons. Make this table, one side properties and then mention electron, proton and neutron. Charge, electrons are negatively charged, protons are positively charged and neutrons are neutral, no charge. Relative mass. Mass of electron is negligible. That's why if we compare the mass of electron with proton and neutron, we can write it 0. Relative mass of proton is 1U and relative mass of neutrons 1U. Position. Electrons are present outside the nucleus, protons present in the nucleus and neutrons also present in the nucleus. What are the limitations of J.J. Thomson's model of the atom? According to J.J. Thomson's model of an atom consists of a positively charged sphere with electrons embedded in it. Clear? But it could not explain the observations made by other scientists. And it was later found that the positively charged particles reside at the center of the atom called the nucleus and the electrons revolve around the nucleus. Next question is, what are the limitations of Rutherford's model of the atom? The Rutherford model cannot explain the stability of an atom if the motion of an electron is described on the basis of the classical mechanics and electromagnetic theory. Second one is, it says nothing about distribution of electrons around the nucleus and the energies of these electrons. These are the limitations of Rutherford atomic model. Describe Bohr's model of the atom. Write the main point of Bohr's model. Only certain special orbits known as discrete orbits of electrons are allowed inside the atom. While revolving in discrete orbits, the electrons do not radiate energy. That is, they do not emit energy. These orbits or shells are called energy levels. These orbits or shells are represented by the letters K, L, M, N. Again, remember these are the capital letters or the numbers N is equal to 1, 2, 3, 4. And also make this diagram. Okay, this is the nucleus and these are the concentric circles which are representing the different orbits K, L, M, and N. Compare all the proposed models of an atom given in this chapter. In this chapter, we have discussed about the Thomson model, Rutherford model, and Bohr's model. Now just compare it. According to Thomson model, an atom consists of a positively charged sphere and the electrons are embedded in it. And this can be represented like this. Okay, this is a positive sphere and these electrons are embedded in it. Rutherford's nuclear model of atom, the positive charge and most of the mass of the atom is densely concentrated in extremely small region called nucleus. And the second one is the electrons revolve around the nucleus in circular paths called orbits. This can be represented like this. At the center, this is the nucleus and these electrons revolve around the nucleus, okay, in path. But there is no fixed path given by the Rutherford. Bohr's model. Only certain special orbits known as discrete orbits of electrons are allowed inside the atom. While revolving in discrete orbits, the electrons do not radiate energy and this can be represented like this diagram. Okay. Summarize the rules for writing of distribution of electrons in various shells for the first 18 elements. And actually these rules are given by the Bohr and Bury. That's why these are also known as the Bohr and Bury scheme or rules. First one is the maximum number of electrons present in a shell is given by 2n square, where n is equal to 1, 2, 3. That is number of shells. On that basis, we can find out the number of maximum number of electrons may be present in the different shells. Like K shell, n is equal to 1, number of electrons are 2 from this formula. If L is equal to 2, 8 electrons are there. If M is equal to 3, maximum 18 electrons are there. If N is equal to 4, maximum 32 electrons may be present. Okay. Second one is the maximum number of electrons that can be accommodated in the outermost orbit is 8. And These shells are filled in a stepwise manner. It means first inner shells are filled, then outer shells are filled. Define valency by taking examples of silicon and oxygen. As we know, the valency of an element is the combining capacity of that element. How can we determine? The valency of an element is determined by the number of valence electrons present in the atom of that element. Or we can say valency is equal to number of valence electrons of the atom of an element. For example, the atom of silicon has 4 valence electrons. Actually, atomic number of silicon is 14. Okay, and if we write its electronic configuration, this is 284. 4 electrons are present in the outermost shell. That's why its valence is 4. Valency may also be determined. Valence is equal to 8 minus number of valence electrons of the atom of an element. For example, the atom of oxygen has 6 valence electrons. Actually, atomic number of oxygen is 8 and its electronic configuration is 2,6. Okay, that's why the valency of oxygen is 8 minus 6 is equal to 2. Explain with examples atomic number, mass number, isotopes and isobars, and give any 2 usage of isotopes. First come to atomic number. The number of protons present in the nucleus is equal to atomic number. For example, nitrogen has 7 protons in its atom. That's why the atomic number of nitrogen is 7. Mass number. Sum of the total number of protons and neutrons present in the nucleus of an atom is known as its mass number. For example, atom of boron has 5 protons and 6 neutrons. So, the mass number of boron is 5 plus 6 is equal to 11. Isotopes. Atoms of the same element having same atomic number but different mass numbers are known as isotopes. For example, hydrogen has 3 isotopes. Protium, that is 1H1. We can say this is atomic number is 1 and its mass number is 1. Deuterium, this is represented as 1H2 or D. Or tritium, this is 1H3 or T. Isobars. Atoms of different elements with different atomic numbers which have the same mass number are known as isobars. For example, this is carbon 14 and nitrogen 14. Atomic number of carbon is 6 while atomic number of nitrogen is 7. Atomic numbers are different but mass numbers are same. Okay. Then give any 2 usage of isotopes. We have discussed in this chapter 4 usage of these isotopes. Any 2 you can mention. Okay. An isotope of uranium is used as a fuel in nuclear reactors. An isotope of cobalt is used in the treatment of cancer. An isotope of iodine is used in the treatment of goiter. An isotope of carbon is used in radiocarbon dating, that is to estimate the age of fossils. Any 2 you have to write. Na plus has completely filled K and L shells. Explain. We know atomic number of Na is 11 and this atomic number is equal to number of protons and sodium atom is neutral. That's why we can say total number of electrons in sodium atom is also 11. And if we know the number of electrons or we know the atomic number, we can write its electronic configuration of sodium. In K shell 2 electron, in the L shell 8 electron, in the M shell 1 electron. Okay, and this Na plus is formed by the loss of 1 electron. Okay, you can write this is Na and this will convert into Na plus 1 electron. Okay, now from which orbit this 1 electron is removed? This electron is removed from this M shell. That's why the electronic configuration of Na plus becomes in the K shell 2 electron, in the L shell 8 electron, and these are completely filled. Okay, that's why we can say that is in Na plus K and L shells are completely filled. If bromine atom is available in the form of say 2 isotopes, bromine 79, this 35 is the atomic number of bromine, and 49.7%. This is the its percentage abundance in nature. Another isotope of bromine is bromine 81 and its percentage abundance is 50.3%. calculate the average atomic mass of bromine atom. We can use average atomic mass of bromine is equal to, this is 79. This is the mass number of this isotope. Clear? Multiplied by the percentage abundance of this isotope, that is 49.7. Multiplied by 49.7. Okay. Then plus, this is mass number of the another isotope, that is 81. And this is multiplied by its percentage abundance, that is 50.3. Okay. If you multiply this, you will get 3926.3 plus multiply these two numbers, you will get 4074.3. Add and divide by 100, you will get 80.006 U, and approximately you can write this 80 U. Okay. The average atomic mass of a sample of an element X is 16.2 U. Okay. Average atomic mass is given. What are the percentage of isotopes X16 and X18 and atomic number is 8 in the sample? Now, how can we solve it? Suppose percentage of isotope X16 is Y%. Okay. And percentage of isotope X18 is 100 minus Y%. Yeah. Now, use the formula for average atomic mass. Average atomic mass of a sample. How can we calculate average atomic mass? That is, mass number of one of the isotope is multiplied by its percentage of abundance. That's why 16 multiplied by Y and plus this is 18 and this is multiplied by 100 minus Y. Okay, divide by 100 and this is equal to 16.2, which is given. Solve it. 16 multiplied by, we will get 16Y, and open this bracket. Then 18 multiplied by 100, we will get 1800 minus 18Y, and this is equal to 16.2 multiplied by 100. Actually, this 100 will go this side in multiplication. And if we multiply these two, we will get 1620. Okay. Now, if we solve it, if this is 1800 transferred to this side, okay, then we'll get 1620 minus 1800, and 16Y minus 18Y we will get minus 2Y. Okay, and difference of these two, that is minus 180. This side minus, this side also minus, that's why minus minus become plus, and we can write 2Y is equal to 180 and Y is equal to 90. And what is Y? Y is the percentage of isotope of X16. That's why we can say percentage of isotope of X16 is 90% and percentage of isotopes of X18 is 100 minus 90, that is 10%. If Z is equal to 3, what would be the valency of the element? Also name the element. If Z is equal to 3, now what is Z? Z is the atomic number. Atomic number of element is 3. That's why we can write its electronic configuration is 2, 1. And in the outermost shell, 1 electron is there. That's why we can say valency of the element is 1. Since the outermost shell has only 1 electron. And when atomic number 3, element is lithium. Composition of the nuclei of two atomic species X and Y are given as under. Okay. In X, protons are 6, neutrons are 6. In Y, protons are 6, neutrons are 8. Give the mass number of X and Y and what is the relation between the two species. As we know, mass number is number of proton plus number of neutron. In X, 6 protons and 6 neutrons. That's why mass number of X is 12. In case of Y, mass number of Y, again number of proton plus number of neutrons. In this case, number of protons are 6 but number of neutrons are 8. Add, we will get 40. Now, what is the relationship between these? You can say in X and Y, number of protons are same. It means they have the same atomic number, but different mass number. Then how they are related? They are isotopes of each other. Now, for the following statements, write T for true and F for false. J.J. Thomson proposed that the nucleus of an atom contains only nucleons. This is a false statement. A neutron is formed by an electron and a proton combining together. Therefore, it is neutral. This is again a false statement. Okay. The mass of an electron is about 1 by 2000 times that of proton. This is correct statement. That's why this is true. An isotope of iodine is used for making tincture iodine, which is used as a medicine. Now, dear student, we are having the two isotopes of iodine. One is iodine 131, okay, and one is the iodine 127. This this iodine 131, this is used for the treatment of goiter, and actually this is one radioactive isotope. What is the meaning of this radioactive isotope? It means it emits alpha, beta and gamma radiation. But this is iodine 127, this is normal isotope, and this is used for making tincture iodine. This is one antiseptic. When this iodine is dissolved in the alcohol and water, whatever the solution we will get, that is known as tincture iodine. And this is used as a medicine, and that is antiseptic to kill or stop the growth of bacteria. Okay, that's why this is a true statement. Rutherford's alpha particle scattering experiment was responsible for the discovery of, answer is, atomic nucleus. Isotopes of an element have, now, same physical property? No. Different chemical properties? No. Different number of neutrons? Yes, this one is correct answer. Different number of neutrons. Number of valency electrons in Cl minus ion. Cl minus ion. Now see, this is Cl. Its electronic configuration is 287. Okay, and when it gains one electron, this will convert into, this is Cl minus. And now its electronic configuration becomes 288. Now, how many electrons are present in its outermost shell? 8 electrons. Okay, that's why number of valence electron in Cl minus 8. Which one of the following is a correct electronic configuration of sodium? Now, if you know the atomic number of sodium is 11. Then distribute these 11 electrons in the different cells. We'll get 2, 8, 1. Now, just see in this option which one is 2, 8, 1. This one. Answer is D. Now, this is the last question of this chapter. Complete the following table. First, try to understand this table. What are the things given? Atomic number, mass number, number of neutrons, number of protons, number of electrons, and name of the atomic species. Okay. Now, in some values are given and some places dash is given. We have to find out what numbers or what will come at the place of this dash. Okay. Now, come to atomic number is 9. Okay, if atomic number is 9, then we can say number of proton is also 9. That's why at this place 9 is there. And this is a neutral atom. That's why number of electrons are also 9. Now, what is mass number? Mass number is the number of neutrons and protons. That's why number of neutrons are 10 and protons are 9. That's why at this place we will get 19. If atomic number is 9, which is the element? Element is fluorine. Clear? Now, in the same way, atomic number is 16 and a mass number is 32. Then how can we find out the number of neutrons? Number of neutrons are actually mass number is the sum of number of protons and number of neutrons. If atomic number is 16, that's why we can say number of protons are also 16. When protons are also 16, number of electrons are also 16. Then this is number of neutrons. This is 32 minus 16, and this is equal to 60. And this is already given. If atomic number is 16, atomic species is sulfur. Now, in the next one is mass number is given and number of protons is given. If number of proton is 12, then we can say atomic number is 12. Okay, and number of electrons are also 12. The number of neutrons, this is 24 minus 12. That's why we will get 12. And which is the species? When atomic number is 12, this is magnesium. Okay, Mg is the symbol. Now, next one is mass number is given and the number of protons given. When number of proton is 1, you can say atomic number is 1. Okay, and electron is also 1. And the mass number is 2. Then number of neutrons, 2 minus 1, that is 1. We can say atomic number is 1. That's why this is a proton, this is a hydrogen. Okay, but mass number is 2. That's why this is one isotope of hydrogen, and that is a deuterium. Okay. Now next one is mass number is 1, number of neutron is 0, number of proton is 1, and number of electron is 0. Now when number of proton is 1, we can say its atomic number is 1. Okay, and when atomic number is 1, this should be hydrogen. But in this case, there is no electron. There is no electron. It means hydrogen contains 1 electron. If we remove the 1 electron, then what we will get? We will get the hydrogen ion, H plus. Okay, you can also see same thing in this table. Okay, thank you.